In this presentation, we will discuss how to read the z-table and how we can make use of the z-table to solve problems involving normal distributions. Previously, we have discussed that any normal distribution can be fully characterized by its mean and its standard deviation. The normal distribution with mean 0 and standard deviation 1 is also used as the reference distribution to compare different normal distributions. It is known as the standard normal distribution, or the z-distribution. The z-table is a standard table documenting the z-scores and probabilities for the z-distribution. This is a part of the z-table that can be downloaded from our course page. There are two sets of numbers on the z-table, the z-scores and the probabilities. The first set of numbers are the z-scores, and z-scores are usually accurate up to 2 decimals. They range from about negative 3.09 to positive 3.09. The second set of numbers are the corresponding lower-tailed probabilities to certain z-scores. The shaded area in the bell curve above is to the left of a z-score, so it is a lower-tailed probabilities. The probabilities are ranged from 0 to 1. For example, the lower-tailed probability of a negative 0.57 is 0.2843, or equivalently, the probability of a z-score being less than negative 0.57 is 0.2843. These are the remaining portions of the z-table for positive z-scores. And let's work on this problem finding probability of a z that is greater than 1.237. So first, we will need to round 1.237 to 1.24 first. And the reason is because the z-scores given on the z-table are only accurate to 2 decimals. And what we do next is, instead of finding the upper-tailed probability directly, what we need to do is we look for the lower-tailed probability. And the reason is because the z-table only provides the lower-tailed probabilities. So we look up for the lower-tailed probability of a probability z that is less than 1.24. And this is found to be 0.8925. We subtract this number from 1 to get the upper-tailed probability. So that means the final probability of the upper tail 1.237 is 0.1075. The next question is a reverse question. Over here, we were told the probability of z less than a is 0.9738. What is the value of a? So it is the probability that is given to us. The z-score is not given to us. The previous problems we have been working on, it is the z-scores that are given to us and we were asked to find the probabilities. What we need to do first is we want to look up for this probability of 0.9738 from this z-table. And we were able to see that right on this table. The value of a should be 1.94. The following question is pretty similar to the one we just worked on. Again, it is a reverse question. We were told the lower-tailed probability of 0.995, and we were asked to find a z-score. Unfortunately, we failed to find 0.995 on the z-table. Instead, we found 0.9949 and 0.9951. They are pretty close to 0.995. In fact, they are equally far away from 0.995. What we're going to do is we're going to use the average of their respective z-scores for the z-score for 0.995. That means A is the average of 2.57 and 2.58. That's going to give us 2.575. Let's work out for some problems using the z-table and the characteristics of normal distributions. Example A looks for the upper-tailed probability for 1.96. Because the z-table only provides the lower-tailed probabilities, we will start with the lower-tailed probability first and then subtract from 1. That means we will use the idea that the total area under the curve is 100%, or 1. The lower-tailed probability for 1.96 is 0.9750, so the upper-tailed probability is 1 minus 0.9750, that is 0.025. Example B looks for the probability between 1 and 2. The region between 1 and 2 is actually the difference between the area to the left of 2 and area to the left of 1. The area to the left of 2 from the z-table is 0.9772, and that to the left of 1 is 0.8413. Their difference is the area between 1 and 2. This question tells us the area to the left of A is 0.0793. Here we are asked to find a z-score for a given lower tail probability. This is a reverse problem. From the z-table, we know A has to be negative 1.41 for it to have a lower tail probability of 0.0793. The z-table is a very useful tool for solving problems involving the z-distribution. That is the standard normal distribution with mean 0 and standard deviation 1. However, when we are dealing with the normal distribution with either a non-zero mean or a standard deviation that is not 1, we would have to convert everything to their z-scores first before we can use the z-table. This procedure is known as a standardization. So we use observation minus the mean divided by the standard deviation to get the z-scores. This is an example where the normal distribution is not a z-distribution. The mean is 0, but the standard deviation is 2. We are told the area between 2 and B is 0.1005. What we need to do first is to convert both 2 and B to their respective z-scores. The z-score for 2 is 1, and therefore B is just B over 2. Now we should feel comfortable to look up the z-table for the corresponding lower-tailed probabilities for 1 and B over 2. The area to the left of 1 is 0.8413. We know the difference between the area to the left of B over 2 and 0.8413 is 0.1005, which is given in the question. So the area to the left of B over 2 should be 0.9418. Now looking up the probability of 0.9418 from the z-table, we know that B over 2 has to be 1.57. Therefore, B is twice of that, which is 3.14. Answers to examples E and F can be found on our course page. This one is a story problem using the normal distributions. We know that the lives of dishwashers are normally distributed with mean 6 years and standard deviation of 8 months. First, we convert everything to number of months, so 6 years is 72 months. I write X follows a normal distribution with mean 72 and standard deviation 8. Part A asks to find the probability of X being greater than 7 years, that is 7 times 12, 84 months. We cannot look up 84 directly from the z-table because 84 is an actual observation. We would have to convert it to z-score first. After subtracting the mean 72 and dividing by the standard deviation of 8, 84 is converted to a z-score of 1.5. The area to the right of 1.5 is the same as subtract the area to the left of 1.5 from 1. That is 1 minus 0.9332, and the final answer is 0.0668. For part B, we first convert 4.5 years to 54 months, and then convert 54 to negative 2.25 z-score. The lower tail probability can be found directly by looking up negative 2.25 from the z-table. The final answer is 0.0112, so that's about 1.12%. Part C is a little bit tricky. We want to find the middle 95% of dishwashers' lives. We started by drawing a bell curve to represent the lives of all dishwashers, with the area right in the middle being 95%. Using the total area under the bell curve being 100%, we know that the two corners at the two ends should add up to 5%. Each of them should be 2.5%. Using the information on the left corner, we know that it has a probability of 2.5%. Looking up 2.5%, which is 0.025 from the z-table, we know that the corresponding z-score should be negative 1.96. Using the symmetry of normal distribution, we know that the upper bound for this middle 95% region should also have a z-score of a positive 1.96. We have the lower and upper bound for the middle 95% region in the z-score. They are negative 1.96 and positive 1.96 respectively. We would like to find their corresponding actual observations now. The formula we have learned before is given here. We would have to find actual observations in a reverse order. For the z-score being negative 1.96, x have to be 56.32. For the z-score being positive 1.96, x is positive 87.68.